This video will continue with the previous one where we learned how to print out integer values with %d, but this time we are going to print out real numbers using %f. Right, so let's put a comment here. Print out some real numbers. Now, to separate this from the previous part we did, then I'm going to output a couple of blank lines, and we know we can do that with do a printf, right paren, double quote, just a couple of \n's. Then we'll skip a couple of lines of output on the screen to just separate what we just did from the part we're about to do. Now, in order to print out real numbers, it's almost identical to what we did with the %d, but the real numbers have some additional features to them that you need to know. So let's do printf, and again, to keep it simple, we're just going to do a %f with nothing else, comma, and then we'll put a real number here, and let's make that pi 3.14, okay, 159. How about that? Right paren, semicolon, and return. So just to the simplest way you can output a real number, which is a number that, of course, has a whole number and a fractional part, is to use %f. %f, the f stands for floating point, and that pertains to how the number historically has been formatted internally in a floating point kind of fashion, but where you use %f to mean a real number. Now, given that, let's go ahead and build this and see what the output will look like for this real number. Now, we'll see what that looks like. We'll run the program. Okay, the output window has popped up, and we have the output from our previous video where we have the %d integer values up here. So then the printf with the two \n's, put two blank lines there, and here's the output we get. Right, so the output for pi, we said our value was 3.14159, but on the screen we get 3.14159. Now, this is very important to remember. The default number of precision, that is the number of digits to the right of the decimal, okay, these numbers here, okay, that default value is always 6. I'll show you shortly how you can change that, but if you just use a %f with nothing else, then it will always give you 6 digits to the right of the decimal. Even if we just had 3.1, it would print out 3.1000000. So it's very important to remember that this is the default output for a real number. Now, let's go back and let's look at some other options for how to output this value. We'll do printf, and we can specify a field width, just like we did with %d. Right, so we'll do our double quote, %, and let's make this, let's say 10, %10f, and let's do a \n. We need a \n really for both of these, so let me go back up at the top and put the \n right there as well. All right, so now this 10 is the same as we used earlier with our %d. It's just going to tell the system to allocate 10 print positions on the screen for our output number. Okay, then comma 3.14159, right paren, semicolon, and we'll go to the new line. So now this is going to allocate 10 total print positions. Let's see what it looks like. We will run the program. The output window shows that in the second case, where we specified a width of 10, then we have some space to the left. So if we count these, then starting from the left-hand side, there are 2 spaces. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the number itself, we have 6 digits to the right of the decimal, a dot, which counts as a print position, and the number 3. So that's a total of 8 print characters that show up. And then on the left, it's padded with spaces. So just like with %d, if you specify the width, the number is output, right, justified in the width of the field that you specify. Okay, another example. As before, if you do not specify a field width that's large enough, let's do a %5f, okay, \n, double quote, comma, 3.14, okay, 159, right paren, semicolon. So in this case, then I know that I have more digits and the number is larger than 5. But if I specify 5, what will happen, and you'll see when we build it that it does ignore that and print the number out. Okay, so we build it. And now when we run the program, and I need some space here so we can see our output. You can see our numbers. I'll scroll up. There we go. Okay, so now when I run this, then you'll see that even though I specified a %5 down here, 5 print positions on the screen, the number is too large for 5. So it takes the amount of space that it needs to output the number. All right, now you probably are wondering, what can I do about these 6 digits over here, or the number of digits to the right? You can control that as well. So you can specify how many digits to the right of the decimal that you want, and that's called a precision. Okay, so let's see how we can handle that. So let's do a double quote %, and let's make this, let's see, we need 8 positions anyway. Let's make it 7.2f, double quote, whoops, \n, double quote, comma, and then our number, 3.141159. What this is going to do is to specify that we want an output width of 7. So 7 positions on the screen, dot, and then after the dot, we put the precision, that is, how many digits do you want to the right of the decimal. So if you specify only 2, then you will only get 2 digits, and it will round up the other fraction to match what you want here. So in this case, we're only going to see 2 digits to the right of the decimal. Okay, so we'll build, and when this is executed, we'll see the output, and here are our 4 lines of output for pi. All right, so the last one, 7.2. Okay, now you can count. Notice first of all that the number of digits to the right of the decimal is just 2, and it's 0.14. Then the period, then the 3. Okay, so that is 4 positions, and then you can count the 3 spaces that are to the left. So this gives you then your formatting control over real numbers. You not only can specify how wide you want the field to be, but you can specify how many digits you want, and you can make that 0 if you want, and it will cut off the digits altogether. So in fact, I guess let's take a look at that. Let's do printf. Okay, double quote. Let's do %7.0. So I want no digits to the right. So %7.0f \n, double quote, comma, 3.14159, right paren, semicolon. Okay, build. Now, yes, I do want to stop debugging, so that was still had my program running, so I had to stop that. Okay, so it has succeeded, and off we go again. Now, that last one, see, we just got the number 3, right? Justified in a 7-space field, so there are 6 spaces to the left. And since I specified no digits to the right of the decimal, then that is what it gave me. No digits to the right of the decimal. So that's a neat thing you might want to use as well. All right, so that's how you can do that. Let's print out more than one line. Well, I'm sorry, print more than one number. So print more than one number per line. And as we did with our %d, we can just use as many printf statements with %f as we want. So let's do a printf. Okay, let's do a double quote. Okay, let's do %. Let's keep our 7.2f for the value for pi, and let's add another %. Let's make it, let's do 5.3. Well, let's make it 5.2, and f for another number, \n, double quote, comma, and we'll print pi again, 3.14159. But since I've told it to print only 2 to the right of the decimal, it will not print all 5 of those digits. And for the second number, let's pick 2.71, which is Euler's number. Okay, right paren semicolon. So now there are two numbers. So the first one is going to have a %7.2f, print position, print width plus precision. So that's where pi will be printed. And then the second number will be formatted in a field of width 5, 2 digits to the right of the decimal. So that's where the 2.71 will go. All right, so let's build it. And now we'll execute the program. So the last printf statement, then, we have two real numbers output. The first one, right justified, 7 spaces with a precision of 2. The second number is in a 5-space field, so you have the 4 characters including the dot, and it also has a precision of 2. So you can continue this. You can print as many real numbers to the screen as you want, formatting them as you wish. I want to remind you once again, though, if you do not specify a precision, %f, then the output is always going to be 6 digits. Okay, so don't forget that. That's very important. Default precision is 6. Now, to finish this up, we can also annotate this output. You can mix in tabs, you can put the special characters, all the things that you're allowed to do with printf, you can. So let's do printf, and let's do some annotation. All right, so something simple here. So let's do a double quote, pi is equal to, and let's do a percent. Let's do like 8.4 this time, f. All right, so that will print pi in a space of in a field width of 8 with precision 4. Then we're going to print Euler number equals, and let's do a percent. Let's do 6.2f this time. Okay, \n, double quote, comma, and we'll put pi 3.14159 and Euler's number 2.71, right paren semicolon. So now we will have some annotations that are included with the output. Need to build it. And when it's finished, we will look at the output. So the bottom line, let's see if I can squeeze it on here. I'll put it down below. Okay, so you'll see you get the values, the annotations, pi, equal sign, and then the number, then Euler's number, a space, a equal sign, a space, and then the value for that. Now, in addition, at the bottom there's an extra space that we've included because we had a 6. So the 6 is going to add a total field width of 6, plus we have the space here. So it really looks like you got quite a bit of space there, but you can control that. You don't have to put the spaces. You can make this smaller if you want to. Okay, so that's what our output looks like there. All right, now let's see if we can mix all these up together. So we have some values now that we've used %d for integers, and now we've looked at %f for real numbers. Let's combine those. So we're going to print a mixture of integer and real numbers. So in a printf statement, then you can combine these field specifiers, %d and %f. So let's do that here. Let's do printf. Okay, double quote, and let's mix these up a little bit. Okay, so let's do feet per mile, and that's going to be, let's do a %d for that one. And I want these to go on separate lines, so let's put that in here as well. So let's do a \n right there. So we'll print feet per mile. We'll go to the next line, and now let's print out pi. So pi equals, and then we'll need a %7.2f for pi, and let's go to a new line. And I'm not putting any space there because I don't want any spaces to lead off the new line. So I'll go to new line, start with the first print position. Now let's say yards per mile, and that's going to be a %d \n one more time. And to keep this short for Euler's number, let's just say E is equal to, and let's do our %5.2f there, \n, double quote, comma, And now we just have to put all four numbers. Okay, so the first one was 5280. The next one was pi, so 3.14159, comma. The next one is yards per mile. That was 1760. And the last number was E, 2.71, right, parent semicolon. Great, so that's a really long printf statement. But what this is going to do is put everything together. We have annotations that you can use, and the %d has to correspond to the integer 5280, and it will. The next output is going to be a real number. So we have %7.2f, and the next number we're printing is a real number. These do have to match up. You cannot output a real number using a %d field specifier. So they have to match up 1 to 1. Third number, yards per mile, is a %d, and there's our output number, 1760. And finally, the last one is another real number, floating point. So 5.2f will print that. So when you're listing a bunch of numbers with one printf statements, you must be sure that the types match up with the field specifiers, %d and %f, with the correct type of number. Now, let's build and print this, or run it and see what we get. It has built. We run. And you'll see that that last long printf statement produced several things. Okay, so we have below the value for pi. Then we have feet per mile on one line. Then we have pi on the next line. Then yards per mile, and then finally E. So this one printf statement with the built-in carriage returns \n produced 4 lines of output on the screen. So you can see now that there's a wide variety of formatting options that you have that you can use to format your output in a variety of ways. Very powerful. All right, that concludes this video, and we will stop at that point.